Hello and welcome back to the second session on solar system. Now the core of this entire lesson or the tutorial I am teaching you in this is how to simplify your codes and how to apply the game algorithm or the game logic. Because why I am saying you this is, see right now here what is our mission? We want sun to be rotating around its axis, and at the same time sun is at one place. You have Mercury rotating around its axis, and at the same time it should also revolve around the sun. Then the same thing should be done with Venus, the same thing should be done with Earth, the same thing should be done with Mars, and Moon should rotate around itself, and instead of on the sun it should rotate around the earth. So the thing here is you cannot write separate scripts for every planet. So it is not a right way of coding. So now we have to use an algorithm. This is what we call as the algorithm, wherein the actual concept is built using the simplest or the minimum lines of code. So we are going to achieve it with minimum lines of code, and that is what I want to demonstrate it today. So for this, now in this session we are now first going to create the script. We are going to create one script for all rotations. All the rotations of the planet will be controlled by one script, and that script will have just one line. How are we going to do it? Let us explore it. So now what I am now going to do is I will come back to Unity, and we are in the solar system, and the solar system project is already open. Now what I will now do is I will come to assets, and in assets I will right click, and I am going to create a new folder, and I am going to call this folder as scripts. And in the scripts folder I am now going to create my script for rotation. So for this I will right click, and I am going to create a new C# script, and immediately I am going to rename this as rotate. I will give it the name as rotate. Okay. So the script is now created. You can see the compilation is going on of the script. You have to wait till this wheel rotation ends. So now whatever script has been created, it is getting compiled. So you have to wait a few seconds till this compilation is over. So once it compiles, you will see the tick mark here. So it has been compiled. Now this Rotate.cs, now I have to edit it in Visual Studio Code. So in the last class itself I have told you to link Unity with Visual Studio Code. First go to Window Package Manager and see that Visual Studio Code editor is installed. Okay. And the second thing is you have to come to edit preferences, and in preferences you have external tools, and here in external tools you have Visual Studio Code. Okay. And in this Visual Studio Code the editing should be Visual Studio Code, and I am going to enable two options here. One is embedded packages and local packages. I will enable these two, and I will click on regenerate project files. So this will make me use the prompts, that is, this is called as IntelliSense. When you are typing something, instead of typing rotation R capital, if I type R, I need a prompt to tell me you are doing wrong. Okay. So for that reason I am enabling this, and already in Visual Studio Code we have already installed the code snippets for Unity, C# code editors, and we had installed 3 extensions when we did the Unity. If you see that video you can see that. So with this done, now I will come back here, I will select this rotate, and if I double click it, this is now going to open in Visual Studio Code, and when it asks do you trust the authors, you click on yes, I trust the authors. So this is the default rotate script we are having. So in this default rotate script, right now what I want is I am now going to what I am now going to do is I will, to make you understand, I am going to write some comments so that you will understand what I am typing. So, in the comment I will write, see, now I am going to use a function called as rotate around. This is the function I am going to use, and to use this function what I need is, in the top I will come to this public sector here, we are going to come over here, I need a variable to, I will write as a comment now, declaring a variable to select the rotation target. Okay. And what is the variable we are declaring? It is public, and the kind of variable we are going to declare is transform. So, even transform, you can declare a variable called transform itself, and this transform actually, the name I am going to give this is target. I am going to call this as target and end it with colon. So, this is going to actually set my rotation target around which it should rotate. The target is set here. Now, after this, I want one more variable to adjust its speed, because all the planets are not going to rotate at the same speed. I have to change the speed. So, to change the speed, I am going to declare one more variable, public, then the type of variable now I declare is int, public int, and here I am going to name this as speed, and I will end it with colon. So, I declare two variables now. One is target, which is a transform type of variable, and second is speed, which is an integer. So, after declaring it, now I will come to update, and in update I am going to use a function which is called as rotate around, and this rotate around is a function. So, before I write the comment below that, I will write the actually the line. See, what are we going to change? This rotation, position, scale, everything is transform. So, I will call the component transform period, and I am now going to call this function called rotate around. So, R is capital, A is capital. So, rotate around, and in this rotate around I will open close the bracket, and in this bracket for rotate around I have to give 3 parameters. So, I will come out and I will close this. This rotate around is a built-in function, built-in Unity by some software engineer who has already wrote it for us to help us, and it has been integrated into Unity, and he has asked me to provide 3 parameters for this method. The parameters that we are going to use is, for rotate around, the first parameter we need is the target. The first parameter we have to mention is the target position, that is across which it has to go and rotate. This is the first parameter I have to enter, and for this I am going to choose this variable which I am declaring here target, and for this target variable period I am now going to add transform, and I am going to get its position. So, this is the first parameter I am giving. So, whatever target I am using, the user is going to select that target position will be the first parameter is rotate around. So, now if moon should rotate around earth means I have to give earth as target, then for the moon the position parameter will be earth. Okay. Now, the second parameter I have to give is what is its direction, how should it rotate. I have told moon you have to rotate around the earth, but how should it rotate? It can rotate in x axis, it can rotate in y axis. So, in any axis it can rotate. So, now I have to tell it in which axis it has to rotate. This is the second parameter I have to give. For this again I am going to choose the target, whatever target variable I have declared, the target period transform, and for direction, for axis, in which axis it should rotate means it should be in this axis. So, it should rotate like this. So, for this the axis we are going to give is up. So, this is the second parameter. I will add a comma. So, I will write here in the comment, the first parameter I need is the target position. Then again I will comment it, rotate around needs second parameter about the axis of rotation. Okay, and that axis of rotation I have set it to up. And the third parameter I need is speed. At what speed it should rotate? For that we use the third parameter, speed. So, I will also put it here in the comment, rotate around, one second, rotate around third parameter needed is the speed of rotation. And when I am using this speed, I want today to introduce you to another term called as Time.deltaTime. Now, in your previous session also I had shown you, we are using this entire code inside update. So, what happens? This code will be triggered every frame. Now, what happens is when you are playing a game, when you are using your game on a slow computer, this will be running at a speed of say 30 frames per second. This command will be executed 30 times. But if you are using with a machine which has a very good graphic card, it will be running at 120 frames per second. And if you are using the same thing on an latest M2 Apple machine, it will be running at 400 frames per second. So, now what happens is, this rotation speed is not constant on all machines. This speed is dependent on your graphic card. However, for me, irrespective of how many frames the game is rendering, I want this speed to be constant based on time. It should rotate based on time and not on frame. So, for this, whatever speed value we are using it here, I am now going to multiply this by a value which we call it as, see, it will automatically show me the prompt time period, and it is called as delta time, time delta time. So, whenever you multiply any value into time delta time, and when you have placed it in update, instead of running the code based on frames per second, it is going to run it on time basis. So, when you add this line time delta time, irrespective of the machine, the speed of this rotation will remain the same. So, that is why for this speed I have now introduced you with a new term called time delta time. So, we have added 3 parameters: transform rotate around, target transform position, target transform up, and speed into delta time. So, with this is the only line we need for all the animations. So, with this one method I can achieve all animations. So, now I will go over here and I will save this file. Only thing is I have added the semicolon also. Now, one thing is this target, now I have saved it. After I save it, I will now come back to Unity. So, wait till the script gets compiled and come to console and see I have no error. Now, what I will do is, I will select this rotate script and I will first attach it to sun. drag this and attach it to sun. So, when I attach it to sun, automatically here in the script, if you come to the rotate script, you have one target variable. As of now, in the target, I haven't fixed any target. Right now, the sun should rotate around its axis only. That is, the target for itself, it is itself. So, I am going to drag sun and I am going to make it the target here. So, for sun itself is the target. So, let us test whether this will work. I will go to file and I will save it. Now, after saving it, I will go and execute this file. So, now when I run this file and if I just check it, oh sorry, it is not running because I have set the speed to 0. I will stop it. Say for example, I will set this to some speed. I will give it some speed value. Say for example, for sun, I will give a speed of around 15. I am specifying a speed of 15. So, once I specify it, now I will go save this file and now I will run and check it. So, let us run this file and now you can see the sun is rotating. See, you can see the sun rotating. So, even here in the game view, the sun is rotating. It is rotating around its own axis. Now, I will apply the same script to all the planets. Now, here what I am now going to do is, I am now going to stop the playback. I will drag this script and apply it to moon now. Okay. So, I will select moon and for moon, say I will just drag it from here and I will apply it to moon. So, I have applied the script to moon. So, when I select moon here and in the target, I will drag moon itself as the target here, and only thing is for moon I am going to set the rotation to around 50. I will set the speed of moon to 50. Then I will select Mars, and for Mars I am now going to select Mars, and for Mars what I will now do is I am going to again select this Mars, drag this rotate and apply the script. Select Mars and in the rotate script setting, I will drag Mars itself as the target. It itself is the target. Only thing is I will change the speed now to 30. I have set Mars speed to 30. Then I will select Earth. I will drag this and put this to Earth. And for Earth, again I am going to drag Earth itself as target for this. And I am going to set Earth speed to around, say I will set it to around 20 or I will make it 30. For Earth I will make it 30 and then I will select Venus. I will attach the script here for Venus and here again I will drag Venus itself is the target and I will set Venus rotation orbit to 20. I will select Mercury, drag this rotate script and attach it to it. And here I will set Mercury itself as the target and I am going to set its speed also to 20. So, now for sun itself is the target, it is rotating by 15. Moon, I have set moon itself as target and it is rotating speed, I have set it to 50. Mars is rotating at 30 speed, Mars itself is the target. For Earth I have set 30, for Venus I have set 20 and for Mercury I have set it as 20. Now, I will save the file and now if I execute the file and if you see that when I run the file, now you can see, you can pan and see, now see all planets are rotating. See, all planets you can see they are rotating. So, Earth is rotating, all planets are moving. See, Moon, Earth, then Mars. So, even if I have to come to Mars here and see, even the Mars is rotating and they are all rotating at different speeds. So, with this set, now the next thing is we have set the rotation, but we also want it to revolve. How are we going to make it revolve? For that, the concept is very simple. I will stop the playback, I will come to sun, and sun is not going to revolve across any other thing. So, that is why I will leave sun as it is. Sun is not going to revolve across any other thing. So, let us leave sun and let us start with Mercury. So, for Mercury, I am going to attach this script once again. So, I am adding this script twice. First time for this the target is Mercury, but for the second time now the target is sun, because Mercury should rotate across sun, and now I have to set its speed. So, what I am now going to do is, for Mercury I am going to set its speed to 50. Then I am then going to select Venus, and for Venus I will apply this rotate script again. I am applying twice. First time it is rotating across its own axis, but second script I am giving it to rotate across sun. I will again add here, sorry, I have to, one second, I have to now, I will select Venus. Venus is selected. For the second rotation, target is not added. I have to now drag sun and make it the target, and again here I have to set the speed, and for Venus I am going to set the speed to around 40. Okay. Mercury, Venus, then I will come to Earth, and for Earth again I am going to add this rotate script again, and for this second rotate script, Earth should again rotate across sun. So, I will drag sun and make the target here, and then I will set the speed. So, now for sun, Earth, I will set the speed approximately 30. So, for Mercury we set 50, for Venus we set 40, for Earth we are setting 30. And then I will select Mars, again I will drag this rotate to here, and for Mars here again Mars rotates around sun. So, I am going to drag this sun and add as the target in the second rotate script. So, remember we are adding twice, once the target is itself and second time the target is sun, and again here I will set the speed of this Mars. Now, for the next Mars I am going to set the speed. Say I am going to select Mars, I have set the sun in the second rotation and I will set the speed to around 25. And finally, now I am left with the moon. I will again select moon, and for moon also I will add this rotation. So, here during the first rotation moon itself is the target, but for the second rotate script it should revolve around Earth. So, I am going to set Earth as the target and not sun. For moon, Earth is the target, and I will set the speed to something like 70. Okay. Now, I am going to save the script and let us now run and see. So, if I execute it now, see what happens is, can you see the entire solar system is rotating? Can you see? And everything is rotating at different speed. See, everything is rotating around at different speed, and you can see moon is rotating around the earth. So, to see it correctly, come to the top view and see. See, in the top view if you see, only thing is regarding moon there is some issue, I think. Why is moon not correctly rotating? It is moving somewhere outside. Okay, let us check it. There is some problem with the speed. Okay. So, now you can see all the rotations happening, the entire solar system is working. So, what did we do? We wrote just one line of code and we prepared the entire solar system. This is what we call as algorithm. Algorithm means we have to first decide what concept. See here, the concept we have applied is we have added a method called rotate around, given it the target position, and by changing the target we are achieving the rotation, changing the target and changing the speed. Okay. So, with this I have actually created the motion. So, the solar system is working. The same concept you can apply to all the 9 planets. Now, the next thing is, if you see the background, you are seeing sky. I need a star background to appear all around. And how to create this star environment, 360-degree star environment, we call this, we are going to use something called as the skybox material. This skybox material, we are going to discuss it in our next session. So, as of now, let us stop this playback, save the file. So, let us continue in our next session. Thank you.